Let me just introduce Aron Szabo, who's been involved in cryptography for over 10 years, and he went to the core of cryptography, dealing with different standards and protocols of cryptography, the different cards that are being used there. And what he's going to show you here is that how these PKI devices could be used in an alternative manner.
No, hát tisztelettel köszöntök mindenkit. Köszönöm szépen a felkonferálást. Engem Szabó Áronnak hívnak.
Warm welcome. My name is Aron Szabo, as it was mentioned. In the next 40 minutes, I'm going to talk about cryptography and interesting things which we jointly discovered with András Nagy and Péter Szabó. Now, what are we going to talk about? First of all, there's going to be a short introduction, following which we would just review what sort of protection mechanism the Windows has, Windows certificate stores, and then we are going to go to the different PIN and password protection. And the third part of the presentation is about going into lower levels of communication channels. Now, what makes the topic timely? I don't know to what extent you're aware of electronic signature, but this is already a legal instrument that has been around since 2001 in Hungary, based on the 99 EU directive. But fewer of you do know, or fewer of you are aware of the fact that the new laws and legal changes and EU regulation led to new notions coming up, new concepts coming up. Therefore, a cryptographic software tokens, PKC12 files could also be used. Now, in the background, what you have in the background is that, of course, to be able to use this in desktop applications as well, I mean, these cryptographic tools. And of course, it's also about the fact that the smartphones are widespreading and mushrooming, therefore it is really needed. Now, the other one that makes the topic and the presentation highly timely is that the National Uniform Card Project is underway, and the information you can hear says that there was already a demonstration concerning the student's card. The personalization is going on. And then you can also see in this chart the arsenal that we're using. This is something that has been mentioned in the PayPass presentation by Balázs. This is something we're also examining, but the point is that here you also have certain cards that will be able of using PKI. Anyway, chip cards. Let's just put this whole story into perspective. Now, it's an architecture coming from Microsoft, but anyway, let's assume that we have an electronic signature software which is using chip cards quite often. As far as the layers are concerned, this is the top layer. On the graphic user interface, I just press the button, like create signature, and then based on the parameters, the selected parameters, what we want to sign, what sort of certificate we determined, what sort of key we use. So these are going to be handed over to a high-level API, MS Crypto API, or the CNG, or a PKC11 interface. Now, it is on this level. When you generate the public key, the secret key, where is the secret key going to be stored? In which store? Now, there are, CSP and later KSP. So in the CSP layer is where you can find the secret one. And these ones, in case of the card, it is the card driver itself. So you have a CSP layer as well. Now, this CSP layer is the one, as I said, is already card dependent. Therefore, this is how they know what sort of instructions to give, to issue, and also what sort of structure is to be considered so that the card would be able to send that further, yeah. Now, these instructions of byte level APE, as it was mentioned by Balázs in the PayPass presentation. So the framework is really absolutely standard according to ISO 7816. But how the data field is compiled, this could be card specific. So as many cards we have connected to the machine, so many different drivers, so many different CSPs might have to be installed on the machine. Now, once it's CSP, I also need to mention that if this is not about the card, but let's say Windows authentication, again, you have certain CSPs, and that also depends on what sort of crypto algorithms you are going to use, or what sort of crypto rhythms it is capable to handle. Now, if you go lower, we see the Minscarp DLL, which is the layer that would decide whether the card connected to the computer will be addressed, or a remote card connected to a remote computer will be addressed. Now, let's get into it. And the first topic we're going to talk about is to examine the Windows inventory, the Windows store, and let's use a hacked Windows server and try to gain secret keys from the Windows environment. Now, handling such a Windows certificate store, or how to export import, I think this is that you've already come across before, either as developers or as users. Now, if you're a developer, you obviously need to be able to use it, otherwise you won't be able to do your work. And also, if there is anything we're developing since Windows Vista, we know that from Windows Vista, the whole protection mechanism has been rewritten, so you need trusted resources. Otherwise, the phones are going to be ringing, and then the users will phone and call the sysads, the system administrators, because the apps will not be working. If someone has a higher level UAC as an authorization level, if you want to install that, you need the trusted code. You need a trusted status for the DLLs and everything else. This is true since Windows Vista. Now, users might have come across such a certificate import when they had to fine-tune the SSL server. Again, here we have to go through this portal story. Now,
importing certificates, so importing next ending import. There's two interesting settings that we'll be talking about now. One is basically about the possibility of exporting these secret keys, encrypted keys. So when I want to be able to be in a protected environment, I do not want private keys to be exportable. The other is, should I put on a strong protection? Should I switch on a strong protection for the key? Of course, there are different levels that you can set, and for every single key, for every access to the key, it will demand a password. How does this really work? This is something that I took from Microsoft page. They actually say that assert open store. Someone opens it, what happens? and all sorts of diagrams that you see here. Basically, if I have an application, I open the certification store, the list of certificates is put over into a memory storage and also the properties, not the private keys, but we will extract those later on. And among these properties, we have the crypt exportable flag, precisely telling us should the private key be exportable later on or not. And not only is it there, of course we can of course overwrite it in our own memory and then actually implement it. From then on, we didn't do this topic first. Last year's Black Hat, for example, Jason Geffner had a very, very good presentation and also published the code. We wrote another one, which is by all means better in that we, instead of the encrypt DLLs, we used an crypt 32 DLL, which means that we could go into older Windows server, for example the 2003, which is more vulnerable. But this is not the real novelty. The real novelty is that we are capable with this application to actually export private keys that have strong protection on them from Windows search stores. How can we do that? Basically, we open the search store, we enumerate the certificates, then we set so-called silent flags. These silent flags basically mean they notify the system that there should be absolutely no PIN codes or etc. Demanded. For example, we were very surprised, and until we did not study this, well, without strong protection, what they did in the background was basically the private key was encrypted, perhaps, or anyway, it was stored down in such a way that it wasn't possible to be extracted. No, setting a silent flag, all this password requirement can be actually worked around. So by rewriting the crypt exportable flags in memory, we can save down in a completely P12 or PLFix file all these keys. I will show you this, but of course a few words about what we can do then, what an IT security manager can say. Well, let's just lean back and wait for Microsoft to do its stuff. This crypt exportable flag should not be exportable or should not be. If we don't want to run, we can also say, or the IT security manager can say, let's use hardware devices for storing keys, and let's forget the Windows Store. That might be the best solution. Or, if we still want to use this Windows Store, because there are some interests that say that it would be beneficial, then again, it's not in the Windows Store that we should be actually storing these software tokens, the file keys, but let us stay with PKCS12 format, because there at least we know that the tokens are actually encrypted. A quick demo.
Tehát látjuk, hogy itt van egy tanúsítványtárba importált tanúsítvány, ott van hozzá titkos kulcs.
We can see, basically, we're trying to export it, it won't really work. This could be protected by strong protection or without that. it's not
Most hát most
relevant.
akkor indítsuk el a mi kis private key
So let us start
exportot.
our private key
Egyben
export.
lefutott minden,
We've had everything run. We have written, overwritten exportable flag. We've selected where we want to store it. We've set a password,
Tehát ezt kiraktuk akkor a file rendszerbe. Most itt
and
nézzük-
we've put it
nézzük
into
egyrészt a
our
PLC
file
számolmányt,
system.
másrészt annak érdekében, hogy bizonyítsam, hogy itt tényleg megtörtént a titkos kulcs exportja is, a maga titkos kulcs így külön, mint AS4.
Here is the key.
Itt megtekinthető. És hát itt látszik is az összes paraméter, amit a szabvány ír hozzá, az itt meg is
And we can
található.
see all the
Nem csak a titkos
parameters,
részek, hanem az összes titkos
not only the
részek.
public parts, but also all the private parts.
Na igen.
Okay?
És hát hogy bizonyítsuk, hogy maga a
And to prove that PFX is importable, so it's easy, we have exported them well. Let us import it back into the store. So we set the password that we used for exporting, and we can see that it's really all there in the search store. If we click on it, there it is. Windows can see the private key.
No, hát ilyen egyszerű akkor egy ilyen
This is how simple it is.
kulcs exportálás a Windows.
This is how simple it is from Windows Search Store.
Pillanat. Jó, menjünk akkor tovább.
So, let's
Nézzük
go
meg,
on.
hogy mit érnek a hardware
What can we do with these hardware? What PIN and password protection on hardwares?
Hát ha valaki olvasgatja mondjuk a Microsoft
Again,
oldalakat, mondjuk
if we look at the Microsoft pages,
leírásokat, hogy autentikusak maradjunk,
just in order to be
már ott is van
authentic,
szó arról, hogy valami
there again it says that some sort of a PIN code cache is actually there with these Microsoft CSPs. We have ourselves have seen
valamilyen chipkártyát mondjuk
that it's some kind of a chip card. We put into the card reader. We launch signature creation, and until I don't pull the card, we can, without giving a new PIN code, I can continue to continue signature operations. So there's some sort of a cache, but this is a session cache. However, what we've been looking at is basically, can the application, can this caching, password caching, for example, storage be done at the application level?
Nos, hát röviden válasz az, hogy igen.
Short answer, yes. If you've seen the crypt set prof param,
Van néhány olyan
there you can see that there's a few parameters that actually apply to transferring PIN codes.
is át lehet adni, illetve
And you can actually hand over PIN codes in different ways, if it's exchange or signature, but for each, it can be handed over. These PIN codes can be handed over.
És ez hogy néz ki egy
And
alkalmazásunknál? Hát most ugye kiválasztottunk egy tanúsítványt, hozzátartozó titkos kulcsot tudjuk.
selected a certificate, we know where the private key is,
A lényeg az, hogy elérkezünk egy ilyen
and with CSP, we get to this crypt set prof param. We have to set basically this PIN code. We have to, in a true real system, it is possible that it's actually, let's say, in a config file. It has to be read, and then it will set it in the background. The application will set it in the background. And basically for the user, you don't really have to have any window whatsoever, because these have all been handed over. You have the data to be hashed, the hash is generated, and the hash needs to be coded with the private key, and because the PIN code has been set, the card will not be actually asking for any PIN code at all.
Hát ez nem tudom, mennyire hangzik ijesztő.
I don't know how scary this sounds.
Azon, hogy most ez most jó.
We were thinking ourselves what, because we actually had to cater for a true, market requirement. If someone actually had this requirement, and the requirement was that it had to be faster than paper-based, and we had to explain to the manager that if he has to sign 100 documents every day and give the PIN code and the password for each of them, it's not going to be faster in any way. Therefore, still to comply with all sorts of legal regulations, we basically had every single document that was read, approved, and then quasi some sort of a config giving the password once. We can then just push through all approved files and create signatures for each of them without actually having to have the user input 100 times, let's say the same pinword, even pulling out the card. So it's not a session-based caching, it is an application-based caching. Yes, so we can use it this way, but we have to be attentive that, again, IT security has to know that if they buy such a software and if they set these passwords, that this system should not use these passwords for anything else, what can they do? Especially we're talking about critical infrastructures, e-government. Well, it does have to be sent for some independent audit. Where even at the source code level, they will check the life path of a password that a user actually inputs, that it should not be stored. Now, if it's stored, then it has to be stored in a protected manner, that it should not be used for any other purposes that the user did not intend. So again, it's auditors who might play an important role here. So, CSP and the layers between the CSP and the card. And if you're here on this topic, let me tell you another interesting thing, my own experience from the company. I don't know if you do any CSP development ever. We had to write for some mobile cryptography application, and we did communicate with Microsoft, because what you have in such cases is that CSP elements, for us it was 2 DLLs, we had to send it to them, to Microsoft, for a code review. So Microsoft audited, and they also added a special digital signature. Apart from these signatures on the DLL, there is a special, separate CSP type signature by Microsoft. Well, everyone has to undergo this, so you can really list any sort of like card manufacturer. During such an audit, apart from the Microsoft audit, a lot of things are checked with such a card. Even at the source code level, they study it. This can actually go on for even a year, and it's quite a cost. So obviously everyone really think it over many times if it's worth it and if they want to market it or not. Small remark, if you are thinking of such audits, you have to know that the common criteria based audit is already 4 different levels, including source code level audit. So that's true for cards. In CSP, what were they looking for? So how did they test the functioning? I've mentioned that CSP, so it's something that has been signed by Microsoft, it's been reviewed. And there is this separate tool that you can, CSP exe, that basically it will, CSP sign exe, which will either include it in these DLL files as an extra security layer, or separately stored in a SIG file. That is the latter we got back from Microsoft. And so if we want to use the CSP, then in the registry we had to set the central DLL. And what we saw is that if this DLL is for any way corrupted, then Windows will not be able to use that. So the primary DLL, which is in the registry, this signature really is verified. However, this DLL that we had imported another DLL. As I said, the whole CSP consisted of 2 parts. And what we saw was that if in the imported DLL we included any change, because the whole signature CSP layer is corrupted, regardless of this, the whole CSP could be used by Windows. This means we could have included anything in a DLL named like this, anything, whatever, whatsoever, and it would have run. and Windows would not have shouted, cried out. So we were surprised. Again, for IT security experts, we either wait for Microsoft to actually correct these, or if they expect us to send the entire CSP part for audit, during usage, all these modules should be also tested by them. Question is, will they actually patch this or correct this? The other thing that you can do is, if you have this or that kind of CSPs that you're using, ask for the precise list, the precise file list, and everything, and then do some sort of their own verification tools that could somehow verify DLLs that the system actually uses, because it is possible that anyone would replace the malicious the DLL with another one. What Windows will do, well, it's a question, because if you look at it, this whole crypto API issue, what we are reading is future CSPs, the so-called KSPs, will not really be going for a code review by Microsoft. Any developer will just launch KSPs, and then God knows what will be inside them. So again, it's an interesting story. So anyone having any sort of homemade crypto layer in a critical infrastructure or in an e-government system, you will really have to make sure, one way or another, how these precisely function. What can be interesting, what is going to be interesting here, is what auditors will find, what they will say about such systems.
Jó, hát és talán a legérdekesebb témakör, hogy itt hát azt ígértem, hogy valamilyen módon bele fogunk.
Most interesting thing, I promise that we'll be able to get a peek into these communication channels. Balázs in the PayPass presentation already mentioned some of these layers or talked about these layers. Despite the fact that I don't know how you are with it, but anyone using these cards, especially if they are audited, we would have assumed that if all this CSP layer is so protected as it is not protected, if there is such much ado about this, we would think that anything beneath it is protected and is sending all these messages on encrypted towards the cards. And I have to tell you, we were wrong. How did we find out? I already mentioned the WinSCARD DLL, which is in the Systems Windows folder, which basically decides that these card level byte messages, where these should go on to. Do they go to the local machine or to some remote machine? And this WinSCARD DLL, well, you can just stand, become in between, and if you can go in between, then you can monitor the traffic. And that is not such a big problem, but that is how we found out that there is absolutely no encryption in these lower layers. So what do you have to do if you want to test this? First of all, you have to create a false WinSCARD DLL. It's like a proxy. It just receives messages and pushes it on towards the card, but meanwhile just creates a nice log. And in this log, we hoped, and it was true, we had all sorts of read and write commands, but what was important, we found passwords. We found the password, And we also found the hash. So something that is sent in during the creation of a signature, it was logged, and from then on, practically speaking, we just had to replay them and replace the hash and then create signatures. What you have to do, apart from having this false WinSCAR DLL, you have to store it down in the right place. This is in the system folder, but we might not have access to the system folder. However, we know from Microsoft descriptions what the DLL precedence is. So even if there's a save mode set, the primary place where such a DLL would be the primary place the application will look for is its own folder. What is an application that uses a chip card? Let's say, for example, the card driver exe. We went and we just put the WinSCAR DLL next to the card driver exe, and we waited. What could we do in order to make it more secure? Of course, we'll not be able to change the order of loading DLLs. I mean, Microsoft would have to rethink the whole architecture, so they will not be correcting it. So what they should be doing instead is that this should be an encrypted channel, so that not even a PIN code or a password can be derived from it. We know that there are such systems. EID framework, tehát amiket ilyen különböző országban ilyen EID kártyákat, ilyen all sorts of, there are different countries using national identification cards, for example. It's a separate topic there that it should actually be encrypted. There's an old, I remember something, I remember reading something where future, some sort of an EID card specification was set forth, and there was a separate SSL type of protocol that would actually create an encrypted channel in this layer. But we know that this does not exist now. Demo. WinSCAR DLL. We said that not only knows that a card is connected to the local machine and it can actually monitor communication there, but it could also do the same thing with remotely. How can this happen? Again, a diagram from Microsoft. Of course, what we're looking at here is an EDP session, and I'll just go on. What we have to be doing here, similar to what I've described already, we have to find a vulnerable Windows server. We have to be able to access it. We have to be able to store down our WinSCAR DLL, and then wait there. Wait for somebody to start an RDP session on this attacked machine, and then going into the machine, accessing the machine to bring with them the crypto, let's say the chip card, along with the card reader that is joined to their home machine. If you remember, the RDP client access interface, you have this under resources, you have this possibility to set a printer, hard drive, or even a chip card channeled into such an RDP session. And then, of course, there is the mistake, because if you actually have channeled your chip card, let's say a sysadmin or the boss, and then he uses it also for whatever reason. Let's say with a sysadmin, you can have tasks. It is true, it happened that you would have to sign logs digitally more and more. In the banking sector, it's a basic requirement. Or the boss just wants to sign a few, let's say, a document, let's say in a public administration, remotely. This could be an option. So if they do this in our log file, we will basically have all this communication included. And what is dangerous here is that while this session is actually alive, until we have all these chip cards channeled into the session, all this communication that we dumped, we can replay it, even by actually just replacing the hashes as if it was another document that we are signing. And without the user knowing, we can actually implement this, execute this communication, and we can actually basically obtain the signature. So what can we then propose to the IT security manager? Either that they should not allow anybody remote access through RDP, or if they have to, then that they should not connect their chip cards. You can see the lowest, the bottom checkbox. Or if someone does, that they should just simply not use it through RDP for any operation whatsoever. I think it's best if they just unplug it. And if the person doesn't adhere to these either, then so be it. I mean, there's nothing I can say. And okay, let us see this short demo that I've brought. What we see here, so we are here in the systems folder. You can put the DLL here. It's actually here on my application. We didn't put it next to the car driver. We put it next to another application. Look at the cert store and all the certifications, who it comes from. It's not important. And then we give all the pin codes, pin code cache, if you remember. We select the certification used for the signature, the public part. In the back, of course, is the private key that the card is using. And what we see here is that this exe did in fact use our false file, and what we are hoping is that it will indeed happen, that it should, what we want is that it should dump it in such a way that we should be able to input it into an open SC. I just input it and I actually have him execute the communication. It runs, it executes. This is where communication with the key, coding with the key happens, and the whole thing runs. And if I go back, here are the important parts. Exit while this shows that the password was handed over, and the 8 ones are the password. The next important element, the 2A, this is where the hash, it's actually in 2 parts, but that's the hash. And what happened with the hash, the coded imprint, you can query it with the C0 from the card. This is how simple it is. Okay, so basically this is where I finish. What I can say in summary is that it is quite evident that developers, malevolent or benevolent, well, have a lot of opportunities in their hands. So it is possible that, again, thinking of critical infrastructures, e-government, I think we'll see an increased importance of whatever we want to use in these systems. Somebody, some way, should first audit them and then should issue reports in which even a simple user can have trust. Thank you very much for your attention.